Hello, welcome to Miss YY channel. Today we are going to discuss chapter 4.1 Chemical Equation. By the end of the session, you should be able to write and balance chemical equation by inspection method and redox equation by ion electron method. Okay, so let's look at the chemical equations. So this one you have learned in your form 5. And to balance a chemical equation, you will add the stoichiometry coefficient to both the left side and the right side, so the number of the atoms on the both sides are equal. So how I normally do, I will give the coefficient 1 to the most complicated compound. So here I can see NH3, CuO, CuN2 and H2O. And normally I'll balance a copper oxide first, which is I can see on left side and right side, there are one copper oxide, and oxygen, there are one oxygen. And then next, I'm going to balance my nitrogen, which is there are two nitrogen atoms. So to balance this, I will add 2 in front of my NH3. And after that, this will make my hydrogen atom to become 6. So to balance the hydrogen atom, I will add 3 in front of the H2O. And now on my right side, there will be 3 oxygen atoms. So I need to add another 3 in front of my copper oxide to balance the oxygen atom. And then to balance the copper, I add another coefficient 3. So this will be the balanced chemical equation. So you can see the number of nitrogen atom is 2, the number of hydrogen atom is 6, and there are 3 copper atoms and also 3 oxygen atoms. And now let's look at the second example, where your aluminium react with sulfuric acid to form aluminium sulfide and release hydrogen gas. So the most complex compound here is aluminium sulfate. So normally I will give it the coefficient as 1. So to balance this, I need to balance the aluminium atom. So I will put 2 to balance the aluminium atoms. And then to balance the sulfate, I need to add 3 in front of my sulfuric acid. So there will be 3 sulfur and 12 oxygen atoms. So now on my left side, the hydrogen has become 6 hydrogen atoms. So to balance this, I will add 3 in front of my hydrogen. So you can check again to make sure that the number of atoms on the left side is equal to the number of atoms on the right side. So if they are equal, means you have done balance the chemical equations. Okay, so next we are going to learn how to balance redox reaction using ion electron method. So the difference between redox reaction and chemical equation is redox reaction will involve oxidation and reduction. So means that your atoms, some of the atoms, their oxidation number have changed. So reduction means that there's decrease in the oxidation number, and the substance may gain 1 or more electrons, and the atoms which undergo reduction act as an oxidizing agent. And for oxidation, there will be increase in the oxidation number, and the substance lost 1 or more electrons, and the atoms which undergo oxidation will act as a reducing agent. So our redox reaction can happen in acidic or basic medium. So now we will see how to balance the redox reaction in both the acidic and basic medium. Now let's look at the example 1, balance the redox reaction in acidic condition. So the step 1, we have to divide the equation into half equations based on the same element. So normally one element will undergo oxidation and the other will undergo reduction. So how to determine which element undergo oxidation or reduction? We can check on the changes in the oxidation number in the element. So you can use dichromic ion and compare with the chromium ion, or you can use chloride ion and compare with the chlorine. So here I will check for chloride ion because it seems like this is more simple to identify. So for chloride ion, the oxidation number is -1, and when it becomes chlorine gas, the oxidation number is 0. So -1 become 0, so we can see the oxidation number has increased. So it means that the chloride ion has lost 1 electron. So when lose electron, it means that the chloride ion has undergo oxidation. So if chloride ion undergo oxidation, it means that my dichromate ion will undergo reduction to become chromium ion. So you write down the half equations based on oxidation and reduction. For step number 2, we are going to balance each of the half equation. So first, we can balance the element other than oxygen and hydrogen. And then we balance the oxygen atom by adding H2O, and balance the hydrogen atoms by adding hydrogen ion H+, and balance the total charge for both equations by adding electrons to the side with greater positive charge. Okay, so now let's apply this in our two half equations. So you can see for Cl- and Cl2, okay, so you need to balance the element. So I will add 2 in front of my chloride ion, so to make it become 2 chlorine atoms. So I have 2 chlorine atoms on the both sides, and in the oxidation there's no oxygen and the hydrogen atoms, so I don't have to balance. So now I need to balance the charge on the both sides. So for the Cl-, okay, the chloride ions, okay, I have 2 chloride ions, so on my left side there will be -2, okay, the charge is -2, and on my right side, okay, chlorine gas, okay, chlorine molecule have no charge, so the charge is 0. So you can see on my left side the charge is -2, and on my right side the charge is 0, so the charges are not equal. So to balance the total charge, I need to add electrons. So electron will add to which side? So 0 is more positive than -2. So I need to add 2 electrons on my right side to balance the charge. So when I add 2 electrons on my right side, it means that my right side will become the charge of -2. So now both sides are balanced. So we will do the same thing for the reduction as well. So dichromate ion, I have two chromium atoms. Okay, I have 2 chromium atoms. So I need to add 2 to my chromium ion. Okay, in front of my chromium ion. So there are 2 chromium atoms at the both sides. And next, we have to balance the oxygen atoms. So to balance oxygen atom, we can add H2O. So you can see there are 7 oxygen atoms. So I need to add 7 H2O. So after balance my oxygen, we need to balance the hydrogen atom by adding H+. And on my right side, there are 14 hydrogen atoms, so I need to add 14 H+. So now that all the atoms on the left and both sides are balanced, so we are going to balance the charge. Okay, so you have to make sure both all the atoms on left and right are balanced first before you balance the charge. So to balance the charge, we can calculate the total charge on the left side and the right side. So on my left side, the dichromate ion has a -2, and I have 14 H+. So the total charge on my left side will be +12. Okay, -2 plus 14 positive, I'll get +12. And on my right side, I have 2 chromium ion. So the right side, the total charge is +6. So it means that the charge on the both sides are not equal. So to balance that, we need to add electrons to the most positive side, which is left side. So to balance this, I need to add another 6 electrons. So if I add 6 electrons, okay, so the charge on the left side will become +6, which will be balanced. So after we balance the number of atoms and charge on the half equations, so now we want to combine the two half equations. So before we combine, we have to make sure the number of electrons, okay, the number of electrons on the two half equations are same. So for oxidation, I lost 2 electrons, and for reduction, I gain 6 electrons. So before we combine, we have to make sure the number of electron gain and loss are same. So I will multiply the half equations, okay, at the oxidation, I'll multiply by 3. So the number of electron can become 6. So when I multiply by 3, it means that my chloride ions, my chlorine, and the number of electrons all have to multiply by 3. So after I multiply by 3, I will get 6Cl minus 3Cl2 and 6 electron. So after you get the number of electrons are similar, then we can combine by cancelling the same species appearing on the opposite side. So 6 electrons, I can cancel the 6 electron on the right side with the 6 electron on the left side. So check if there's any similar species. Okay, if there's no more similar species, then we can combine both the oxidation and reduction half equation. So when I combine, I'll get the new equation, which is 6 chloride ion plus dichromate ions plus 14H plus, and then to produce 3Cl2 plus 2 chromium ion and 7H2O. So, okay, this will be the final answer, okay, for the balanced redox reaction in acidic medium. And you can check the equation again, okay, to make sure that the number of all the atoms are same on the both sides. So 6Cl, 2 chromium atom, 7 oxygen atom, and 14 hydrogen atoms. And also you can check the charge as well. So negative 6 plus negative 2, so negative 8 plus positive 14, so you'll get positive 6 on your left side. And here you have 2 chromium ion, which is positive 6. So this is just to double check, okay, that your answer, okay, and the equations are balanced. Okay, so sometimes the question will ask you to balance the redox reaction in basic medium. So if for basic medium, okay, we will follow all the steps, okay, from 1 to 5 on how we balance the redox reaction in acidic medium. So means like the step from 1 to 5 is similar to we balance in acidic medium, okay, but for basic medium, okay, we need to add 3 more steps, okay, which is the 2, 3, and 4. So we need to calculate the total number of H plus in the equation, and then we're going to add hydroxide ion to both the sides. Okay, so the number of hydroxide ion added is equal to the number of hydrogen ions in the equation. Then we combine the hydroxide ion with the hydrogen ion to form H2O. So in basic medium, okay, normally we will have the hydroxide ions being produced. That's why we are adding hydroxide ion to cancel off the hydrogen ion. Okay, so let's say if, like example 2, the question asks you to balance the redox reaction in basic condition. So what we are going to do is we are going to balance this redox reaction as what we did in the acidic medium, okay, which is a step 1 to step 5 until you get a balanced redox reaction in the acidic medium. So this is a balanced redox reaction which we got from the acidic medium questions earlier. Okay, so this is already we have balanced earlier just now. So if the question say basic condition, you need to do 3 more steps. Okay, if it's in basic condition. So what we are going to do is you calculate the total number of hydrogen ion, which there are 14 hydrogen ions. So normally hydrogen ions is because it appear in acidic condition. Okay, so for basic condition, we have to add OH hydroxide ion to both the sides. Okay, so I will add 14 hydroxide ion on my left side and 14 hydroxide ion on my left side. So when you add hydroxide ion, okay, they can combine, okay, or we say they are cancel off, okay, it will cancel off the hydrogen ion to become H2O. Okay, so here 14H plus combined with 14OH minus, I will get 14H2O. So you can see there's no longer hydrogen ions in my redox reaction. Okay, it means that you can see there's a hydroxide ion. So it means that the redox reaction
occur in basic condition. And finally, you can simplify all the you can simplify if there's a you can simplify the number of water molecule. So here on my left side I have 14 water molecule and on my right side I have 7 water molecule. So I can simplify this, which I cancel the 7 H2O on my right side, and the left side, when I cancel 7 it will be left 7 H2O. So the final balanced redox reaction will be 6 Cl minus plus diion plus 7 H2O will produce 3 chlorine molecule plus 2 chromium ion plus 14 hydroxide ion.
If you like my videos, please like, share and subscribe. Thank you.